Everyone, so my name is Divakaran Santhosam, matrix number 192472. So I'm taking this video for our assignment EEE 3502 Communication Engineering, and first of all thank you to Dr. Mariam to let us to do this wonderful mini project. So case study. So as you can see, this is the modem of internet supplier for my house, and it's actually using fiber optic. If you can see here, this cable is actually fiber optic. So what is fiber optic and how this fiber optics is actually helping to give us internet? So as you can see, I have shown you the fiber optic cable just now. I cannot cut it for you because that's my internet supply, but I can show you what is the cross section of the fiber optic cable. So as you can see, I've drawn the cross section of fiber optic. So it has two layers of glass inside, which is made from silica. This is made from silica, and also it has a one protection layer. So this is the core is the medium where the light will travel in zigzag, and also this cladding is make sure that the total internal reflection is happening, and this protection layer is to protect these both layers inside. So what is so for the transmission of internet, we are actually using the concept of total internal reflection. So before we go into this total internal reflection, we must understand the concept of refraction. So the refraction is meaning the bending of light when travel across two different medium of different refractive index. So when the n1 refractive index of the above object is higher than where the incident light is coming, so light will bend away from the normal light. It will bend away from the normal light. So when this is incident angle, when this incident angle is increased to a part, this bending light will be perpendicular to the normal line, which is parallel to the surface. So when it is parallel to the surface, this incident angle is known as critical angle. So when your incident angle is larger than the critical angle, that's when total internal reflection happens. So this incident angle, when it gets larger than the when this incident angle gets larger than the critical angle, instead of it goes away from the medium, it will reflect back into the first medium, into the medium where the source is actually coming from. So back into the concept we showed just now, the cross section of fiber optic, this cladding, actually the refractive index will be lower. This core is actually the refractive index will be higher. In our drawing here, our core will be the refractive index of n2 and cladding will be the refractive index of n1. So this will make sure the light is always travel inside the core. Light is always travel inside the core, and the information can be passed in terms of light. So as I said, this total internal reflection, this concept of total internal reflection for light actually can bring us internet. So how is it possible? So from our mobile phone, let's say any message is wanted to be transmitted to another phone. So this mobile phone will will change our signal into binary. So binary, there is only two conditions, where one will be 0 and another will be 1. So this 0 and 1 will be transformed into electromagnetic waves. So when it is 0, when a signal is 0, it will travel in low frequency, and when the signal is 1, binary is 1, it will travel in high frequency. These electromagnetic signal waves will be picked up by our telecommunication tower. When our telecommunication tower picks up these electromagnetic waves, what it will do, it will for binary one, it will actually create a light so that it can be traveled into the fiber optic, or when it is 0, it will have no pulse. So when it is 1, when it finds a binary 1, it will send the pulse into the fiber optic cable. So the special thing about this fiber optic cable, it actually travels all over the world, even under the sea. It can travel few hundred kilometers, and it needed to be amplified later. So if you want to see about how this undersea cable works, there are a lot of YouTube video that is available. But once the fiber optic cable picks up, and then it will transfer to another telecommunication tower which is nearby to the phone that we want to send, and it will transfer back the electromagnetic fields and will be picked up from our to our sender's mobile phone. So this is how actually internet works, where the electromagnetic waves from our phone sends to telecommunication tower, and from telecommunication tower the message is transformed in the form of light through fiber optic cable, and also will be transferred back to telecommunication tower, and also to our sender's mobile phone or any other tablet or any other gadget that uses internet. So this is how totally total internet reflection actually helps in transmitting messages through internet. So let us compare optical fiber and also with our traditional copper wire. So before I go there, if you remember, I said that this optical fiber, the light in optical fiber can travel up to like 100 kilometers before it need to be amplified. This is due to the loss that is caused by attenuation, which is caused by absorption and also dispersion of light. But this is much lesser loss compared to the copper. So other than that, optical fiber is also cheaper, faster, costs us lesser, and also much safer and also hard to tap compared to traditional copper wire. So in overall, we can say that optical fiber is better than traditional copper wire in almost all the aspects. So this is our video. This is my video for optical fiber. Me, Divakaran Santhosam. Thank you.